is Muhammad Hakim bin Abdul Rahman Adrin, DF 1901 and 38. Today I will present about the introduction of the brown coconut fibre. In the current age, soil reinforcement is a wide area of research. This is because of there are many occasions in which the soil is not of good quality at the shallow depth, and deep foundation can be costly. There are many occasions where the soil is not sufficient quality, even at the greater depths, and it might not be possible to substitute the soil. Thirdly, for different purposes, there are situations of underground construction, such as tunnel or underground air bases and bunkers. Soil reinforcement is done to a certain extent, as is naturally observed by the roots of plants and trees that hold the soil together and prevent soil erosion. This is one of the main reasons why a great deal of focus in many parts of the world is now being placed on forestation and deforestation reduction. We also have several natural and man-made material along with the plant that can be used for restoration purpose. The light of Geotechnic and Geotechnic, including artificial material, hair fibre, cellular fibre, and coconut fibre are the few examples of the natural materials such as material can be used for soil reinforcement. For example, jute bags are very commonly used to strengthen the embankment of the river and prevent erosion to reduce damage during floods. Using coconut fibre can prove to be a highly effective means of strengthening the soil. There are two types of coconut fibre: brown fibre and white fibre. Brown fibre are obtained from mature coconuts, while immature coconuts are used to obtain white fibres because they are thick, coarse, strong, durable, and have a high abrasion resistance.
My name is Nurhani Saidin, and I will explain to you about application. Direct shear tests were performed on the soil sample. Direct shear test is an experimental technique that aims at evaluating the shear strength of the soil material. Shear strength is defined as maximum resistance when subjected to shearing that a material can withstand. Direct shear test is commonly considered as one of the most frequent and basic tests to derive the strength of the soil, and can be carried out on the sample that are undistributed and remolded. The procedure for the direct shear test is: weigh the soil instruments, measure the shear bulk diameter and height inside the shear unit, position the shear piece. By fixing the two screws, the lower portion of the shear bulk is stabilized. Assemble the bulk of shear, which is put porous stone and the gripper disc together. Place the sample inside the shear device and place on top of it with a filter paper, porous stone, and loading cap. To obtain the mass of the sample, weigh the mass of remaining soil. Set shear power to none. Null the original gauge of the dial, horizontal and vertical. Place the vertical load on the sample. Due to consolidation, calculate vertical displacement. On the shear device, set the selected rate. Start the process of shearing. Take reading step regularly before the shear stress rise and fall, or until the horizontal deformation exceeds 10 to 15% of the original diameter, depending on shear intensity.
My name is Karisa binti Karama. So, the initial findings demonstrate by the specimen without any reinforcing materials, the result obtained at standard stresses of 0.5, 1.0 and 1.5 kg per centimeter cube. Then, using coconut fibre as a reinforcement, the direct shear test was conducted at 1.0%, 2.0% and 3.0% by soil weight. The fibre were combined with the soil specimen at random. Once all the necessary direct shear tests were carried out, for each specific scenario and at each value of normal stress, the shear strain curve was plotted from which the maximal shear stress was estimated in each event. This was accompanied by diagram of maximal shear stress and normal stress in order to evaluate the internal friction angle value for each event. The difference of the internal friction angle with fiber material was analyzed, and the optimal necessary fiber content was determined.
My name is Muhammad Izzuddin bin Muhammad Jamil, BF190087. Today I will be presenting the case study for this report. First is the manufacturing of the coconut fiber. The first step in the process to get coconut fiber is husking. It involves the separation of the husk from the harvested fruits. To obtain good quality coir, the fruits are harvested when still green. The second step is retting, which is essentially a curing process. This process leads to the composition of the pulp of the husk that allow it to be separated into core fibers and core pith. Last step is the extraction of fibers. The outer skin is peeled off for separating the fiber from the pith. Then the fiber are clean and dry. Next is the material that used in this research. Number one is sand as a soil sample. It goes through sieve analysis as per the provision of IS 383 1970, provided that the sample belongs to zone 3, having a fineness modulus of 3.19. Second is coconut fiber. The table shows the properties of coconut fiber used in this research. For the result and analysis, it will be presented by the next presenter. Thank you.
Hi, my name is Nurli Izzati and I'm going to explain about results and analysis. As the result and analysis, there are two types of stress-strain relationships. One for unreinforced sand and another one for sand reinforced at 2% by weight. However, the results shown in stress-strain relationship for sand reinforced at 2% by weight are higher than the ones with unreinforced sand. Besides, it also shows the highest angle of internal friction between three samples of percentage of coconut fiber and unreinforced sand, while the angle of internal friction versus percentage of reinforcement graph shows that the maximum value of internal friction is 39.30 degrees. So, based on the result from this case, it can be said that the implementation of coconut fiber on sand shows an increase of shear strength since it provides ductility to soil. Also, analysis of the soil capacity is feasible through analytical calculations. Thank you.
My name is Muhammad Kemal bin Muhammad Noor. My matrix number is DF19010. For today chapter, I will talk about the conclusion for this project. The effect of environment of sandy soil by the use of coconut fiber has been analyzed in this paper. The results show an increase the volume of angle of internal friction. On utilization of reinforcement, the maximum increase in the parameter is 21.70%, corresponding to an optimal fiber content of 2.1%. Beyond the optimal content, a reduction in the angle of the internal friction is obtained. Thus, it can be concluded that coconut fiber can be utilized for enhancing the shear strength in parameter of the sandy soil, and its availability due to the widespread cultivation of the coconut in the country can prove to be an efficient economic measure of reinforcement of sand. Further research can be conducted on efficient method of random placing of the fiber in the soil for yielding better result. Research can be also conducted on further enhancement of cultivation of coconut and the manufacture of coconut fiber.